morning, class, and is Engineer Isaac Niteko Okai, and I'm your lecturer for Maths 3, which is Vector Calculus. So we have the BCE level 200 morning, as well as the BCE level 200 the evening class. So you're welcome to this session. I think this is the first time of reaching you through this medium, and I hope you're going to enjoy as we progress along. There will be other medium where we will share the assignments, and then we will have to work on your own individually and send the assignments through the portal. And of course, there will be Zoom sessions where we'll have to meet you one-on-one and then to explain issues. That's where we can also interact. But for now, we are doing some these videos which will actually give you information as to the course we are running for this semester. And so this semester, our course is titled Vector Calculus. Vector Calculus, right? Vector Calculus. And it is Engineering Maths 3, Math 3. And the main components of this course I'll send to you by the portal, but virtually we're going to do courses on vectors. Remember, we did vectors in Maths 1, and we are going to base on that knowledge, and then we'll move ahead. So we're going to take a quick revision of what vectors are, and then from there we'll look at the calculus of it. In calculus, when we talk about calculus, we are talking of vector fields where we do what we call differentiation, and then we'll also do integration of vector functions. So, without much ado, I will request that you go back to Engineering Maths 1 and then take your notes and revise the basic things that we all learned about vectors. So this short video is about the introduction, and then what we need to do is that revise our vectors, and then also look at the rules of differentiation, integration by substitution, integration by parts, and all these techniques that we learned in Maths 1 are going to help us in trying to differentiate functions. In this case, we're going to look at vector functions. And so I will still advise that you go through your notes, and then if there are any issues that you want us to look at, we can actually look at them. So for today, we'll start with the basic tenets of vectors. What are vectors? We learned that vectors are quantities. Vectors are quantities which have both magnitude and direction. So vectors tells us what they are and the direction that those quantities are heading towards. And so in engineering, we can have vectors can be vector fields, force, displacement, acceleration, and the like. And then the other side of vectors, we have what we call scalar quantities. Scalar quantities are quantities we use in engineering, like temperature, like distance, where it gives us only magnitude. It doesn't show us the direction. And so we start with vectors. Vectors are always shown by direction line segments. A vector starts from a point A to a point B. So A is the initial point point, whereas B is the final point or final destination point. And so we can define vector AB by a directed line segment which is denoted as AB like this, AB. And so this is a vector, and we said that vector has two quantities. Vectors have one, they have magnitude, and they have what we call direction. And so if you are looking at vector AB, the magnitude is denoted as magnitude AB, and then the direction is what we have seen, direction AB. So we can take an example. The point A has initial coordinates, as well as B, which also has initial coordinates. And the coordinates in engineering either lie in space, which we call 3 dimension, or they lie on the plane, which we call 2 dimensions. And so as we progress in our study of vectors, we're going to look at both. We're going to look at vectors which operate on in planes, and vectors which operate in space. So like I said, point A has coordinates. So if we take the situation where we're working in space, so point A can have coordinates to be x-axis 1, y-axis 1, and then z-axis 1, right? And then point B, since it's also in space, will have s-coordinate 2, y-coordinate 2, z-coordinate 2. So it means that when we talk of vectors, the definition of vectors, it means that if we want vector A, vector B, what we're going to do is that we take the coordinates of B, the final point, final destination, minus the initial destination, or this destination, right? And so what we'll do is that vector AB will now be defined as AB, where the final destination has coordinates B, which is x2, y2, z2. Then you subtract the initial coordinates, which is coordinate A, which has x1, y1, and z1. And so what we do is that we subtract component by component, which means you take the final s component and then subtract the initial s component. Likewise, you take the y final component and subtract the y initial component. And lastly, you take the final z coordinate z2 and subtract the initial coordinate, which is z1. So let's try it this way. So vector AB is going to be like x2 minus x1. Then when you come to y2 minus y1, and then we'll have the z component, z2 minus z1. And so that defines vector AB, and this is the direction. But we also learned from beginning that the vector AB, vectors have 2 components, the direction and the magnitude. We have seen the direction, and then the magnitude, as we define by this formula, the magnitude of vector AB will be the square root of the squares of each of the components, which is x2 minus x1, then you square it, plus y2 minus y1, then you square it, and then plus z2 minus z1, and then you square it. You remember that this is the magnitude of the vector AB, and this is the magnitude. if we had done that for 2 dimension, then you realize that the z components will not be necessary, and so it's going to be shortened with the z components being out of the equation. And so for 2 dimensions, as I'm saying, for this is for 3 dimension, that is in space 3. Then for 2 dimension, if A and B, the initial and the final coordinates happen to be on a plane that is 2-dimensional, then our vector AB is going to be defined as x2 minus x1. Then that is the x coordinate, and then y2 minus y1. So in such a case, finding the magnitude of vector AB if it is on a plane, so its magnitude AB is given as the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So that is when this vector is in space, is on a plane that is 2-dimension, and we call the 2-dimension to be the Cartesian, that the OXY plane, that's 2-dimension. And so to wrap up on this session, we're going to we have a vector defined by 2 coordinate points. If it's in space with the 3-dimensional, we have the vector being represented by x2 minus x1, y2 minus y1, z2 minus z1, and then the magnitude is defined by this formula, that the square root of differences in their respective coordinates, and then that is how we'll define the vector AB that is in space. However, when our vector is defined on a plane where we're talking of 2-dimension, that is on the OXY plane, then we'll have vector AB being defined as the final point minus initial point, and that is what we came up to. And then the magnitude of this vector is defined by the square root of the differences in the respective coordinates, and that does it for the definition of vectors on a plane. So we'll end up this session, and then the next session we shall look at examples how to calculate vectors in terms of the magnitude and the direction. Thank you very much for paying attention to this presentation, and then the next, I'm welcoming you to the next session where we'll take examples to illustrate what we have done so far. Thank you very much.